Yes, we are live now. So, guys, this, as promised, will be the ticketing architecture where theater ticketing server is being built. There are ways in which this architecture has been written in different ways. It has different approaches, and I think I can show you this one architecture which is going to be very unique in terms of giving you that function. So this is where RabbitMQ comes into the picture. So I hope it is visible. Yes, it is visible. So let me just give you a quick intro about it. So unlike some other applications, today, like, you can think of loads which comes up in different ways. Like, your customers can come up in different platforms like mobile, web. If you are very eager to build something called as progressive web apps also comes into the picture. I know how things are weird over the system architecture thing, but I can explain you this one very quickly. So let's move on, guys. So a laptop and a mobile is basically that one place where all your customers might do it. Like, somebody might be in the office, they can say like, okay, let me just book a ticket for a recent movie. Let it be like Hobbs and Shaw. That was the last movie that I went before the pandemic, and thank God I at least saw the movie. So let's just go about this app service. App service will always be designed by anybody who is really working on the front end and back end aspects. Like, it's kind of a monolith, but yet a microservice, if you are thinking so. And when I said progressive web apps, you can still write an web application and deploy it as an application tomorrow. So that's where progressive web apps comes into the picture, and they are more latent, and like a lot of functionalities will not be available. Like, most of your GPS, camera, everything will be accessed, but like there are some parts where you need to optimize some things based on the GPU, DPU, like, if available, it will not be available. So this is where the database comes into the picture. So database is the place where you get stored. So this will be in the form of a text, and text will be always be in a CSV, XML, or it can be in the JSON format also. So it depends on how we are storing the data set. So this is how things are. So on your premises, there are card readers, on premises service, which is like, okay, recently PVR has also given out this option where, like, you can use a card reader and you won't get a ticket. Actually, you won't get a physical ticket these days. It will always come in your QR code and you can really show it up there. So this is how on premises works. So let me just give you that one quick scenario where you're basically working on some architecture, and basically your architecture is like, you have three different places where it can be ordered. But what if somebody pops up and says that I need a particular seat in a M row 25th seat? What about that? So it's a blunder, because you can't have two or three seats with the same aspects, right? You can't really judge yourself saying that, okay, like, I wanted that seat, I didn't come here, so what about next? So if that seat gets booked, so it will be saved in the JSON format, text format, CSV format, and it will be processed in the real time, and even millisecond delay will also be there. So this is how this architecture, I just chose this architecture because it has a very bright insights. I have other architectures also where it's like this, the cloud storage architecture. I hope it is visible, and it's also Netflix. It's Uber here. It's still the same Uber here. Oh my God. What happened to one? Yeah, the Uber, Netflix, a lot of architectures are coming up. But like, let me just go on with it, with my ticketing system now. So all these are being collected. So what do? You just give it to a data scientist, you just give it to a developer who really can take this data and deploy it and just see how the things really works. So this is how you can make a little bit of changes in your architecture. Like, you can basically do something like, okay, I'll use some Azure functions, where some microservices, I'll just deploy it using functions. What is this all about? So this is where things can get real weird, and you can really start messing around with this architecture. So let me just check with this, and I think to an extent this. Worker nodes. Okay, fine. Let me just go to this afterwards. So Logstash will always be there, Kibana, and a lot of things. So ETL pipelines is one which I have defined here. So this is where again an app service comes into the picture, where again if you want to log in, oh god, what happened? Yes, it's focused. So RabbitMQ is here, app servers, and there's a Redis cache, which is a database cluster. We can go on, and there is a NoSQL database here. So a real-time database, and now a master and slave architecture, which is working on it. So, and Hadoop, HDFS, and everything, these are like, you're just storing chunks and chunks of data, and now you're processing it. So when you're scaling such kind of systems, Hadoop, HDFIs, Pig can also be used to some extent, but like I've never worked on extensively on Pig because I've never worked on architecture like in firms or anything. So this is your typical load balancers, where your load balancer starts working. So there's a Varnish thing which is coming up. So we'll just go on to it in a very short time. And there's a GCM APN notification channel, where this is basically just used for your messaging. It's nothing more. So audience or the client just gets the message saying that, okay, what is this? What is that? So this is where notification channel comes into the picture, and a custom domain name services comes into the picture. And this is how simple it looks, but when I start explaining, it will go complex. So let me just go on. So this part is simple, where you have an app, a database, and everything is stored, processed by data scientist or a developer at one given point of time. So this is where complexity starts. An audience as a client comes into the load balancer, he sends a request, and there is a Varnish which gives a custom domain name, which gets inside the app services, and there are different layers to it. So when you're doing this will be probably with respect to the reception of the message from any client who wants to order a ticket, to probably the premises of the theater. And here what we are seeing is basically that one complete architecture of it. So this was consolidated to this basically. So now, there is a GCM, APN notification channel, where you will be basically sending messages saying that, okay, a client has popped up, so load balancer, get ready. And what next? This Varnish function is basically which is just a function of front end, which just says, okay, he's clicking on that. So now it just pops on to this app service. This app service will have multiple layers of databases, which basically says, okay, is using this feature for this amount of time. This is how Google makes money. They just store your information at one given point of time, and they just say, this is how he's using the money. And now Redis cache is here. So Redis cache is basically whatever gets stored here will be channelized in such a way that it goes and sits in the pod in a very nice fashion. It just goes and sits like a baby. It need not have to be like, okay, I've done these many things, what next? So its function is to just manage the nodes, the parts, and everything in the database. So it need not have to be. And here is where the NodeSQL comes into the picture. This is where Cosmos DB from your Azure and everything pops up. At one given point of time, you can really think like, okay, what have I done? So it's a NoSQL database when there's a kind of an SQL required, but you will be scripting based on the dependencies. You'll be scripting based on the required amount of compute that actually required to store the data. And Hadoop and HDFS and all these things are just basic introduction to whatever the batch processing of the data. So there's vertical scaling, horizontal scaling, Lambda and Kappa architecture, a lot of things coming up. So stay tuned for the other series also. So forget this part for a while. This part is a little complex because this is where big software comes into the picture. There's Redis, there's Kafka. when you say RabbitMQ here, this is actually sending a request here. This is also going into the app service. Worker nodes and everything will be optimized by using Kafka itself. So you need not have to worry. So the task will be allocated for one UI or an UI saying that if he cancels it, just give a message saying that you have cancelled this ticket. If it doesn't cancel it, wow, successful. You have your seat booked, and send him a notification like 1 hour prior or anything like that. So this is how your worker nodes will be assigned with a lot of tasks, and this is how things are. So ELK, Elasticsearch, Kibana, Logstash. Elasticsearch, Kibana, Logstash is Elasticsearch, Logstash, Kibana. This is where things go wrong. Like, you are basically optimizing your data on an elastic.co platform like ELK, which also involves some ETL pipelines, and there are other transform functions. ETL is extend, transform, and load. This is how data moves in out of it. So when I said Lambda and Kappa architecture, Lambda is an architecture where you have the serving layer, whereas Kappa is basically just like processing. So your Lambda fits in here and your Kappa fits here. So this is how things are. So sorry, Lambda fits here, Kappa fits here. This is where serving layer comes in. And worker nodes are also here. So this is also where Lambda architecture comes into the picture. So when you think of such complex entities, like this entire system working in the real time, making decisions in the real time, you can really think the amount of complexity which has gone in. It's not like they have just called the Docker client, they have just not the Docker client, the Docker image, and they have just put the RabbitMQ here, it's working or something. It's API over API versus API. It's like huge stack of APIs. So this is how things are in RabbitMQ. So RabbitMQ will just make sure that your requests are being sent with no hawks. In OS, in the concept of OS, I think here you can see this book, right? It's from the Greg Gagne. So this is a book on OS. So I think probably in future, if I get a chance, I'll do a series on OS also, where he comes across the word called as deadlocks. Deadlocks are basically where you're completely seizing the functionality of it. But you're saying, okay, calm down, boss, calm down. The kernel is still working, so you need to do other tasks. And this is how deadlocks and a lot of things in your architecture is being optimized in the real time. So yes, this is just a brief intro on this complete architecture. I think probably next we'll move on with something more. Thank you all. And the broadcast